Hey guys, great to be back with y'all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. You know, it's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
Hello and welcome to 5 Minute Math. Today we are looking at the third grade concept of real-world number pairs. This is the standard 3.5 kilograms statement. We're using item number 18 of the 2018 release of Stars. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, and then unpause it. It looks like we're trying to solve this problem. It's talking about we're having a sale on books. So the sale price of each book is $6 less than the regular price. People buy it for less. So if we were to do $10 less, so let's just do a few example ones to make sure we understand how that would work. And so we would say, let's say something costs $10. And then we would say, here's the sale. The sale is minus $6 because that's what $6 left means. So then your sale price, your SP, would be $4. So the sale price is going to be $6 less. And so if we were to do $20, you still take $6 off, and that would be $14. And we can go on, but I think you kind of get the point here. Even though there's 4 separate tables here, we need to be thinking of these like input-output tables. So they're giving us the rule. So in this particular situation, they're giving us the rule or the relationship between the numbers. We're looking for minus 6. And so let's just take a look at these examples here, regular price. And so I'm just going to put a minus 6 right here. And let me just take that and bring it down here. So they're saying 12, this is the first one on F, minus 6 equals 18. Well, that doesn't work, but I think you could see why that doesn't work. That's actually close. They just gave you the wrong operation. If you were to add 6 to each one, you'd get 18. So that's a plus 6 on this table. If you were to take your 19, add 6, you would get 25. So that's not going to work because it doesn't make any sense for your sale price to cost more than your regular price. You want your sale price to cost less. That's why it's on sale. You don't want it to cost more. So F is the right number, simply the wrong operation. So the regular price let's see what minus 6 looks like here. Let's bring it down here. 18 minus 6, and they say it equals 12. You know what? That looks like it might work. Let's double check the next one. 25 minus 6, does that make 19? Yes, it does. Let's double check these two. 32 minus 6, 26, yes. And then let's say 39 minus 6 is 33. All right, so this is most likely going to be our answer, but you always want to check H and J. Maybe we missed something and another one looks like it works. I'm going to have to go back and look at our thinking. So we've got, let's look at minus 6 right here for H. I'm going to bring this all the way over here. I'm kind of running out of room. So 36 minus 6, they say makes 34. No, that doesn't make 34. Obviously, it's going to make 30. So really, it looks like they have a minus. It looks like the rule is going to be minus 2. So if I were to take this next one, 30 minus 2, yeah, that makes 28. So here's the problem. In this particular rule, in F we had plus 6. In H we have a minus, but it's minus 2. So all of these books are on sale. In H, they are just $2 off, and we're looking for $6 off, so that's not going to work. And then let's take a look at J. J is an interesting one. We're going to bring it down over here. So 36 minus 6 equals 6. Now, 36 minus 30 makes 6, but take a look at this. What if we were just add a dot right here and a dot right here? Guess what we have? We have a division, and that works. And look at this next one. 30 divided by 6 equals 5. So this has got a divided by 6 rather than a minus 6. So that's wrong, and our answer is G.
Okay, let's look at this problem together. It says, Eli and Daniel are brothers. They made a table that shows their ages during several different years. Complete the table. So we have a table. We have Eli's age. He's 11, and Daniel's age is 3, and so on. Then we have some blank spots in here where we need to figure out Daniel's age, and we figure out Eli's age. So we're going to look at it. We're going to try to evaluate and try to figure out what operation we're going to use on this table. Okay, it looks like both of my labels are the same. We're talking about years here. So typically, whenever our labels are the same, that means it's going to be an addition or subtraction problem. So I'm going to circle addition and subtraction. Okay, I'm going to look, and typically we read the table from left to right, just like we read everything else. So to go from 11 to 3 gets smaller. To go from 13 to 5, things get smaller. 15 to 7 gets smaller. 2 operations make things smaller. And that would be subtraction and division. And it looks like I circled subtraction twice. So I believe the row on my table is going to be subtraction. So I'm going to subtract something from 11 to make it 3. So if I want to count up from 3 to 11, that'll tell me how much I need to subtract. So that'd be 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like 8. So 11 minus 8 equals 3. Okay, 13 minus 8. Let's double check that. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13. That does look like it. There's a difference of 8 there. We'll check this one. Minus 8. So I count from 7 to 15. See if the difference is 8. That's 7, 8, 9, 10, 11, 12, 13, 14, 15. The difference is 8. So to figure out Daniel's age, I would go ahead and subtract 8. And I know 19, take away 8, that's 11. And on this table right here, okay, right here I've got Daniel's age. And I know the difference in their age is 8, but I know that Eli is older than Daniel. So right here I do plus 8. And 16 plus 8. So that's 16, 17, 18, 19, 20, 21, 22, 23, 24. So when Daniel is 16, that means Eli will be 24. So what it wants us to do right here is describe the pattern you see between Eli's age and Daniel's age. Okay, and the rule, basically the rule on this table is -8. Okay, follow along as I read. It says, Randy's Sunday shop offers different toppings for Sundays. For each 2 scoops of ice cream, the customer can choose 1 topping. Randy posts this table for customers to use when ordering Sundays. So, it says 2 scoops, you get 1 topping, 4 scoops, you get 2, and 6, you get 3. So, what operation is going to be the rule for this table? Okay, I'm looking at my labels. I have scoops and toppings. They're different. Typically, when I have different labels, I'm going to use a multiplication division rule on my table. And I'm looking at it, 2, 1, 4, 2, 6, 3. They get smaller. I got 2 operations to make things smaller 100% of the time, and that's division and subtraction. So looks like the rule on this table is going to be a division rule. What could I divide 2 by to make it 1? Yep, I know 2 divided by 2 equals 1. So what is 4 divided by 2? Yep, 4 divided by 2 does equal 2. What is 6 divided by 2? And 6 divided by 2 is 3. So my rule on this table is divide by 2. Let's go and look at the question now. And it says, which shows the relationship between the number of scoops and the number of toppings. So F, the number of toppings is half the number of scoops. Is that true or false? That looks like a true statement. So I know that 1 is half of 2, 2 is half of 4, and 3 is half of 6. So that is a true statement. So we're going to look at the rest of the statements. G, the number of toppings is equal to the number of scoops minus 1. Okay, well, let's check it out real quick. 2 minus 1 does equal 1. That's a true statement. Let's see if it works on the next one. 4 minus 1 would be 3, not 2, so that's not a true statement. And 6 minus 1 doesn't equal 3. 6 minus 1 is 5, so that is a false statement. Answer choice H. The number of toppings is double the number of scoops. Is that true or false? Okay, number of toppings is 1 to 2 scoops. 1 is not double 2, 2 is not double 4, and 3 is not double 6. So for that statement to be true, that would have to be 4, 8, and 12. So that's a false statement. And last one. The number of scoops is half the number of toppings. Is that true or false? Okay, so the number of scoops would be half the number of toppings. So that would have to be 1/2. 2 half of 2 is 1, and half of 3 is 1.5. So that's a false statement also. So the true statement is F. The number of toppings is half the number of scoops. Okay, it's time again to complete your independent work. I'll have a page in there for you to print out and work your work out. But if you don't have the ability to do that, make sure you use some scratch paper and work these problems out. And remember, on input-output tables, it has to be true on all the data. You know, we might be able to use addition or subtraction on some of them. It'll work on one of them, but it's got to be true on all these statements. So make sure you take your time, work all these problems out. If you have any problems or any questions about anything, please email your teacher or send them a message on Schoology, and best of luck to you. We'll talk to you later.